international docking adapters for the space station will be delivered in Dragon's unpressurized trunk. The adapters will enable space station docking of commercial crew spacecraft, including the Boeing CST-100 and the Crew Dragon from SpaceX. Here to talk about the preparations that NASA is making for these changes are Lisa Colorado, the Associate Program Manager for the Commercial Crew Program at NASA's Kennedy Space Center, and Bill Dowdell, Technical Director for Ground Processing for the International Space Station Program here at NASA's Kennedy Space Center. Later, we'll have Boeing's Chris Ferguson and SpaceX's Hans Koenigsmann join us to talk about their commercial crew spacecraft. So Lisa is the Associate Manager of the Commercial Crew Program, which is leading NASA's efforts to develop the next United States crew transportation and rescue service capabilities to and from the International Space Station and other low Earth orbit destinations. Lisa's been an integral part of the Commercial Crew Program leadership team since June 2012 and helps direct the budgeting, contracting, safety, and technical areas of the program. Bill Dowdell serves as the Technical Director for ISS Ground Processing. He ensures that requirements are met for the critical spares that we fly to the International Space Station, and also plays a role in hosting the ground processing for the science being performed on the ISS. Bill's been with NASA for 26 years and at KSC for more than 31 years and has worked on both the Space Shuttle and International Space Station programs. So Lisa, Bill, can you talk to us a little bit about the advancements we're making toward the Commercial Crew Program, the work that's been done and on the International Space Station, and what we need to do to continue to be ready for these commercial crew spacecraft?
Okay, so before we start, I would like to say something, and that is how impressive it was to sit here and listen to those two young folks talk about getting something ready to fly on the ISS. And something that really struck me is that they said simpler is better. That's very true, and that is exactly why we developed the International Docking Adapter the way we did. Mr. Suffredini and others in NASA called for us to take a look at some of the prior systems we had in development and ask the question, is there something else we can do that's simpler, fewer parts, that we're going to be able to perhaps hand off to industry to be able to build like copies of? And so, again, that really resonated with me, that those guys also discovered that basic tenet of engineering, that simple is a good thing. Let's see, to talk a little bit about the mission. First of all, glad to be here. Looking forward to all this hardware that's going to space, both the science and the hardware itself. We mentioned the International Docking Adapter that's flying. We got an oxygen tank that's flying as part of the nitrogen-oxygen recharge system. First time we'll get this oxygen tank on orbit. That system is a reusable one. So that's a good deal for both for NASA and the American taxpayer, because we can refly them after we take them up and replenish the supplies on orbit. Something else that's flying this time that struck me that I thought I'd mention is the Microsoft HoloLens is flying. And that's a new tool that we're going to give to the astronauts to use. It's basically something they wear while they're doing a task, and it enables both the ground controllers and the flight crew to communicate better, and the ground controllers are better able to see what the flight guys are doing. And it also has the ability to project holograms and a lot of other capabilities. I haven't read up completely on it.
We got a great briefing about it yesterday, too.
Okay, well, you guys already know that. But anyway, it just struck me that here we are. We've got something that's capable of projecting holograms as the astronaut is using it. And I couldn't help but think, if you guys have ever tried to put something together that came in a box at home, if you had somebody that could see what you were doing and be able to project while you were doing it, how that would be handy. So I'm expecting we'll find good use for that. Let's see, for the International Docking Adapter, we've got a fair amount of work ahead of us to reconfigure Space Station to be ready for that. I'm going to refer to my cheat sheet here. There's a lot of planning going on right now to relocate the permanent multipurpose module, to relocate a pressurized mating adapter, to install the International Docking Adapter. First thing we'll do is we'll move the permanent multipurpose module. We'll move it from the Node 1 nadir to the Node 3 forward. As a result of that, we'll free up a berthing port. After that, we'll be able to take the IDA number 1 and install it on pressurized mating adapter number 2, and that's on Node 2 forward. Then we'll take pressurized mating adapter number 3 from Node 3, and we'll move that over to Node 2 zenith. So Node 2 will effectively become the docking port that has 2 docking adapters on it as we go through this sequence of events. And then Last is we put the IDA-2 on that PMA-3. And so that work is being planned, both the EVAs for it and the work that the ground controllers have to do. It's going to complete over the next months. I think by the time we get into the end of the calendar year, we expect all that to be in place. And I think that's kind of a good summary of where we are with the IDA and the major things that are going up on this mission.
Okay. And I also wanted to congratulate Heidi and John, and just, it was very inspirational to us. I know that sometimes the students say that we do inspirational work that motivates students, but honestly, I think it comes back like tenfold when we hear something like we just heard earlier today. So thank you. And I also want to say, there were two things that they both touched on, too, that are very relevant to what we are doing here at Commercial Crew, or what we're striving and will be doing. They talked about the precious time for crew on station. So every minute of time on station is like gold to us, right? So it's such a unique and valuable asset that we have, and the science that we do up there is really what the Commercial Crew program is all about. So we are trying to get our crew to station, and in our case, once we have this capability, we will be increasing the crew size, which equates to more valuable time to do the science and the research on board, which is exactly what it's for. So they already learned that lesson on a small scale, and the other thing they mentioned was, the value, or the wasteful, as John put it, what a waste it is to bring the compound or the material back. So in Commercial Crew's case, we are going to actually have, the vehicles are going to have increased capability, so cargo capability to upload and download, down mass. So they already learned that lesson. So on a small scale, some of what you guys are doing is exactly the purpose of what we're trying to accomplish with our program. What's going on right now with the IDA and the hardware, to us, that is just like a huge boost to us. We've been working for a couple of years, and anytime that the hardware comes, so delivery of a docking adapter, and recently we had SpaceX did their pad abort test, and some of the work going on at the pad over on the Air Force side to build a crew access tower and all that. Those are all just the building blocks and the steps that we're taking to get where we're going, and it's very much a boost, and we're really super excited about it. We're going to get there soon, and we're looking forward to it.
Great. So we'll take some questions. Also, we'll continue taking questions from those online. If you want to send a question to us, use the hashtag AskNASA. So questions about Commercial Crew and the International Space Station program, this mission. Ken?
Hi, Ken Kramer for Universe Today, Northeast Astronomy Forum. You touched on the 7th crew member. I wonder if you could amplify a little bit about additional cargo and experiments that'll have to be brought up for that crew member, and how that will really augment the science that's done on the station when you have this 7th person. Thank you.
Yes, so we have requirements to have 4 crew on CST 100 and the SpaceX Crew Dragon. That will increase the crew capability up to its max on station to 7 total. That's 1 more than we've had. And so there's a lot of time that the crew is working on, other things. They have to do a lot of things to maintain the station, and there's just a whole series of work. But the more crew time you have up there, like I said, is more valuable, that you can do more science and research. So that's what we're really excited about. So I think, our capability that we're adding is really good for all of us as a community. And then you had another part of the question. I'm not sure I captured the second part.
Well,
the payload or the cargo they had to...
You're going to have to bring up more cargo to support the 7th person for science experiments. So how will that play?
Yeah, it's a good question. I don't know. It's a big difference between 6 and 7 to support an extra crew member. The real value in our systems is additional cargo capability that we can take up and down to do more science and resupply and that kind of thing. So I think the amount of cargo that is required for the 7th crew is, I don't know what the exact number, but it's not huge.
Okay. James?
Hi, James Dane, Florida Today. Lisa, the funding for next year that Congress has approved or so far indicated it's going to approve is considerably below what you had requested. So can you tell us how that might affect your milestones coming up near term and ultimately your timeline for actually launching a crew?
Yeah, so I knew there'd be a budget question, right? Always difficult. Obviously, the best way to avoid unnecessary schedule delays and costly reworking and the changes that come with changing a schedule and a budget is always difficult. We're still hopeful. We don't have the number. We don't have the exact number yet. So we as always we will adjust to whatever the people at higher B's tell us what we need to live within. But the best way for us to stay on track and meet our goal to have the capability by 2017 is going to obviously depend on the budget. Mm-hmm.
Hi, Casey Ayers with NASA Social. I was wondering if you could speak about any of the key differences, strengths or weaknesses behind Crew Dragon versus CST-100. Is one platform more suited to certain tasks than the other, or is it essentially a competition to see which model proves to be most effective for ISS?
I don't know that I'm the best one to talk about the differences between the capabilities technically. I would just say they're both very unique. They both have benefits that each one has, and they're different from each other, obviously. But the key is that they both have to meet our basic fundamental requirements for safety and performance, and to keep our crew safe. That's the most important thing. They may be able to, when they're up here, they may be able to talk a little bit more about the capabilities that they have.
Jim?
Jim Siegel, I'm with Celebration News and Spaceflight Insider. You mentioned a little bit about the goal of beginning the commercial program and getting people up into the ISS by 2017. Correct. So could you talk a little bit about what happens after that? What are some of the other milestones or timelines? And is this kind of an indefinite thing that's going to go out or just until the end of the space station program or what?
Sure. So our goal is to have the capability by 2017. You're correct. We right now have plans for each Boeing and SpaceX to have a minimum of 2 missions that we want to buy that take our crew to station and back. So that's 2 apiece. We could have the capability to have up to 6 per provider, per company, and we will decide that later. But eventually, we're going to have 2 missions a year. This is our current plan, 2 missions a year to station and back. And currently, the station is planned to extend until 2024. And so we will be operating up until 2024. That's the plan as of now.
Any other questions for Lisa or for Bill? Okay, thank you. And so now we're going to take a look at some of the work that Boeing has been doing for its commercial crew program and bring up Chris Ferguson.
The first new crew access tower to be built at Cape Canaveral Air Force Station since the 1960s is taking shape, as Boeing and United Launch Alliance work toward flights of the CST-100 spacecraft in 2017.
This is an extremely exciting time. It's great to be doing the construction after so many years of designing, and the excitement is incredible in terms of we're putting American astronauts back on American rockets through the commercial crew program, and we're bringing Atlas back to its heritage from the Atlas Mercury program.
Workers are assembling the tiers that will be stacked atop each other at Space Launch Complex 41 this year. It will take 7 tiers to complete the 200-foot-tall structure, designed to meet the unique needs of astronauts and their ground support teams.
So we've added lots of features to this tower that you would not normally have on a normal, everyday integration building.
The tiers will be stacked at the launch pad between Atlas V liftoffs and outfitted with wiring, elevators, and emergency evacuation systems before crews begin launching from the pad to the International Space Station.
So Chris Ferguson is the Director of Crew and Mission Systems from the Boeing Commercial Crew Program. In this role, he has comprehensive oversight for crew interface in the design of the CST-100. He's also a former shuttle astronaut, flying on 3 space shuttle missions. He piloted STS-115 and commanded both STS-126 and the final space shuttle mission, STS-135, logging more than 40 days in space. Can you tell us a little bit more about Boeing built both the International Docking Adapter and you're working on the CST-100 and clearly out at the launch pad?
Absolutely. So it's been an exciting time. You've seen some in the video about some of the hardware changes that have been occurring around the Kennedy Space Center. Of course, that was our crew access tower. Launch Complex 41, where we'll launch off of on an Atlas V, rolls out very shortly before the actual launch, and there's no facility there to get the crew up and into the vehicle. So our access tower, as you see, is beginning to take shape. It'll begin construction here. You see the segments taking shape offsite, but it will begin to be segmentedly built here in September of this year, and it'll be finished in March of next year. So a new 20-story complex, which will change the horizon here at KSC, which is always good because every time we see something poke up into the horizon, we know that exciting things are happening. So again, just one of the more visible segments of what is happening with the Boeing spacecraft. Let's talk programmatically for just a second. We've had a very good year. We've completed a couple of the major milestones that have enabled us to receive funding for what we call PCM-1, or Post-Certification Mission 1. This is the very first servicing flight to the International Space Station, scheduled for late in 2017, December of 2017. And in order to do that, we had to complete some changes, some late arrivals for our critical design review, and that was done earlier this year. And then we completed our what we call certification baseline review, which essentially is our roadmap to what it's going to take to become certified to carry American astronauts and foreign astronauts up to the International Space Station aboard our craft. So with that, we received, like I said, an authority to proceed for post-certification mission number 1, which is very exciting. And like Lisa was saying earlier, these missions are scheduled to occur 2 per year. So you'll see a request for proposal for certification mission number 2 coming out later this year, and of course SpaceX and Boeing will both compete for that as well. So it's a very exciting time. I want to take an opportunity to answer a question I heard earlier about, hey, what is it with the Boeing and SpaceX vehicle? What do they have? Strengths, weaknesses? Is this ultimately going to become a competition? And I think the best way to answer that is just in terms of redundancy. We all learned a very valuable lesson back when we lost Columbia in early 2000. That we had a single string path to the International Space Station at that point, and fortunately, we had our Russian partners that enabled us to keep the space station alive and well and crewed. We look upon redundancy as an essential component to success long term in space. So having redundancy within our own shores is a fantastic thing, and it provides flexibility to both NASA, it provides flexibility to our human spaceflight program, and I think ultimately it turns out to be a very good thing it's a win-win for everybody. So I don't think this is ultimately a competition, and I think you'll see 2 partners going forward in collaboration and servicing the space station with the idea that always one will be ready. What else can we talk about? Let's talk about the spacecraft itself. We have, just not far away from here, of course, most of you may know that we're building the vehicle here at the Kennedy Space Center, our factory, in essence, over in the old Orbiter Processing Building number 3, OPF number 3, which was a complex that had the orbiter facility and the what we call the engine shop for the Space Shuttle main engine. Boeing, in collaboration with Space Florida, have taken that facility over. We've put some pretty dramatic improvements in the infrastructure, and now we have what we call our lower dome and our upper dome, the 2 parts, the infantile parts of our vehicle over there for our structural test article. They're taking shape. We're eventually going to move our office spaces over there, and then in the larger, what we call the high bay, where the orbiter was, There's some infrastructure changes going on in there, new facilities, new floor, and we're actually framed out right now what we call our ante-room, where we'll do some of our hypergolic work. So it's just so interesting, and you see it not just on the horizon in the form of launch towers, but you see a lot of other infrastructure changes going on at the Kennedy Space Center. And as we come up on the 4th anniversary of the very last space shuttle flight, I think it's very welcome news to the folks here who have been integral to the space program since the early 60s. So we're very excited about all that, and it's just a thrill for me to be a part of it and to see us all go forward. And I too have to congratulate Heidi and John back there. Some great words, and what I really like is they're clearly thinking about the future. You know, space station is a resource we have in low Earth orbit right now, but we all know it's not going to last forever, that we must be thinking beyond that, and clearly the thinking beyond that is taking men and women from this planet beyond low Earth orbit to someplace else, whether it's Mars or an asteroid, and sustaining astronauts for a long period of time. And clearly we have a young man and young woman, along with their team from Golden, Colorado, to guide us that way. And I'll tell you what, I wasn't doing what you're doing in 8th grade. I was doing something else. I really have to I have to take my hats off to you. The world is in very good hands. Compliments of your team. Thanks.
And what is that sitting next to you?
Oh, I'm sorry. So the IDA, the docking adapter, the PMAs, the mating adapters that are up on the International Space Station are going on about 15, 20 years old right now. So this will actually, one half of it will mate to the existing PMAs that are up there, and the other half will form a new standard for spacecraft that dock to the space station. It extends the length of the docking port by about 30 inches, and as we'll all see tomorrow, one of them will go up to mate to PMA2, and one will go up, I believe, later this year to mate onto to the PMA that'll go on node to the zenith, as Bill had said, to form a new threshold to the space station through which every astronaut that will go back and forth from the American segment will pass. So it's an exciting time for us. Of course, this is Boeing built, and was manufactured at our facility out in Houston at the Product Support Center, and we're thrilled to be a part of the mission and looking forward to see another piece of Boeing hardware become a permanent fixture on the ISS.
Great. It sounds like we should take some questions. Ken?
Ken Kramer for Universe Today and Northeast Astronomy Forum. Chris, can you talk a little bit about when you'll actually be building the first vehicle, I guess, and you're building the structural test article now. Talk a little bit about that. And more importantly, when do you start building the first one? Thank you.
I'll tell you, Ken, it's a very aggressive construction program. As you mentioned, the structural test article is our first. When that's complete, that will go out to a Boeing facility in Huntington Beach, and there we'll stretch it, we'll pressurize it, we'll irradiate it, we'll do all those things you do with a structural test article. In a few short months, we're going to begin construction on what we call our qual test vehicle. This will be very much flight-like. As a matter of fact, we'll probably turn this around and actually make this a flight vehicle one day. But that will have all of the subsystems, the environmental system, the electrical system, the batteries, all the parts that it takes to make it an actual habitable spacecraft. That will also spend some time at various test facilities throughout the United States. And all the while these vehicles are in construction, we'll begin to build the very first flight article, which is the crewed flight test vehicle. And that'll come probably early next year.
When might
it will be done. Actually, we just changed our schedule to get some synergies from the various tests and line them up in a better position. That'll be done in time to support the crew flight test in December. The orbital flight test is actually first, and that's scheduled for July. And we're building the vehicle specifically to support that. So the OFT spacecraft will not do any testing beforehand, but it'll be ready to go in July.
And we'll take James.
Sure, James Dane, Florida Today. Chris, in the vein of the partnership between you and SpaceX, this is obviously kind of an interesting mission in that they're carrying up the adapter you built, and neither of you can get there, I guess, without that hardware in place. So I just wonder if you could maybe touch on sort of the unique aspect of that collaboration on this flight.
Well, Hans, you better take good care of that docking adapter, because we are both counting on it. But it's interesting and ironic, I think, how that obviously both Boeing, SpaceX, Sierra Nevada, a lot of competitors began the commercial crew venture back a few years ago. Of course, Boeing and SpaceX were selected for final contracts to deliver material and astronauts, and I just think this is a great element of the partnership that we have going forward. I think later this year we'll see the second docking adapter go up, and clearly we are all in this together. It's a partnership with the Commercial Crew Program and with the various vendors, and we're eagerly seeking to reclaim the business of delivering crew and cargo back to the space station on U.S. soil.
Great.
Jim Siegel, I'm with the Celebration News and Spaceflight Insider. You've kind of touched upon a collaborative relationship with the other companies who are building vehicles. I guess there's 4 of them altogether. So beyond working together on the docking adapter and berthing, I'm interested in whether there is any other kind of collaboration that's done among the various companies, or are you kind of like strictly secret, don't talk to each other, lock up everything at night, that kind of thing?
Well, we don't collaborate directly with each other. We have a boss here. We report to our main customer, Lisa, in the Commercial Crew Program, and we count on them and their team to ensure that if there's synergies that can be applied across the various competitors, that they apply them. So, again, we don't work directly with one another, but we work through Lisa and her team, and we like to think that, collaboratively we're bringing together, a partnership that works to the best interest of ISS. But we do still lock the door in the evening.
I think we have a question in the back over here.
What is it?
Wait for the microphone.
Hi, Chris Kerr with the NASA Social Group there. What does it actually mean for the United States to get back into delivering their own astronauts into space, and what are the advantages? What's next with that?
That's interesting. If you're asking us, it's huge. It's our whole life and job, right? I mean, that's what we're doing. That's the whole purpose of our mission. For the country, it means really going back to kind of our roots. We've been doing this for decades and decades. We've had partnerships with companies, like Boeing and now SpaceX and some new players. It's just, it's really inspirational. I think it's a matter of national pride. Not to say that we don't have great partnerships with our Russian counterparts and all, but and Chris talked a little bit about this flexibility for the agency, and space is a growing industry in its own right. With or without the NASA role and the human element. For us, it's all, it's about that. But we're hoping with this commercial vehicle, and they're able to use their vehicles for missions, that are not just strictly NASA missions. There'll be people like John and Heidi's work going up, and, it'll just be between the commercial partners and whatever future holds for space experiments and stuff. We're just kind of in the transition stage for us.
If I may, Chris, that's a great question, and Lisa touched on it. Of course, NASA is our prime customer. That's who we're going to serve. We're going to take astronauts up to the International Space Station, but perhaps there's other business opportunities here. There's Bigelow Aerospace is working on inflatable modules, that one of which you'll see go up to the International Space Station soon here. But there will be hopefully a destination in low Earth orbit that replaces the International Space Station someday. It's likely not to be a U.S. government project, but a private company who pulls it together. And that company that pulls together that destination in low Earth orbit is going to need transportation back and forth. So what you see is the transition perhaps to space of what the aviation industry went through 100 years ago. We have this great capability to do things, and what do? We deliver cargo with it, right? Like we delivered the mail initially, and then as the industry matured, we began flying passengers around. So fast forward 100 years, well, we're delivering commercial cargo to space now, and pretty soon we're going to be delivering U.S. paying astronauts on a commercial vehicle. So it's very interesting, very compelling time to think about where the business might lead.
I think we have a few questions from social media.
Yeah, Explorer is asking, this is probably best for Lisa, what is the time constraints for space station reconfiguration for commercial crew?
So the time constraints for reconfiguring the station?
Yeah.
Well, I don't know the exact schedule, but as Chris, when we were talking about the schedule that we're on to get our vehicles and the CST-100s and the Crew Dragon to station is very aggressive. So what we do on the program side, and we're talking about partnerships that we have with, our industry partners, we have a pretty strong tie and relationship with the ISS program, obviously. So that's kind of one of the intermediary kind of roles that we play as a program, is to understand our provider schedule, understand station schedule, and how we make sure what's needed to be done on station links up and is ready to go for our providers as well.
And I think
and it's different for each one.
I think what Mike Suffredini said yesterday was that we're on track to finish the reconfiguration work, the primary reconfiguration work, by the end of this calendar year.
Yeah.
And another question, this is Kurt, and he's asking, this is for Chris, does Boeing have any plans to christen the individual CST-100 craft with a name?
Yes, we do, and I think you'll see that very soon.
I think there's a question in the back.
That's okay. Hi, Erin Sharoni here with NASA Social. As somebody who's been in space and someone who actually both of you work very hard to keep putting people into space, what's the, I guess if there is one single biggest current hurdle that you see with regard to getting humans into deeper space and keeping them there for longer periods of time?
Yeah, so this is kind of, I was talking earlier about the stepping stones, so it really goes back to, our predecessors, the Apollo and then shuttle, and now we have commercial crew, and we kind of work and we work and learn and grow, and we kind of build off of the previous successes and sometimes failures. You talked about failures in the past, and so we kind of are building on that. And it's a little bit like when you travel or you're planning a trip, even for you, and you're just going around the block to a grocery store or something. You can get there with your bike or car or walking, and then it gets more complicated as you go further, like around the world kind of trips. So the whole build up and of the capability, and the biggest human element of it is sometimes it's maybe not as obvious, but sometimes a psychological kind of element to having humans physically be able to sustain that kind of environment long term. The effects of radiation is kind of a technical issue that we have, and then also I think there's a lot of psychological. It's a long trip, and a lot of alone and focus, and have a lot of work to do. So it's kind of a combination. That the human element definitely adds to the difficulties.
Our horizon is really low Earth orbit. And that's where we're focused on. And if our biggest hurdle, this is a commercial program. NASA formally certified itself when it built spacecraft. We are working very closely with Lisa's team, but we have a very long checklist that we have to go through before we consider, or our customer considers us certified to fly humans. That's a big deal. So checking off all those blocks as we get to the end of the program, and getting Lisa and her team's buy-in that it's good enough to fly humans. If I had to say what our big hurdle will be, it's getting through all those check blocks.
And I guess I should have mentioned too that part of the reason and the reason we have the commercial crew program is to allow commercial industry to take over that role to low Earth orbit that we have been doing and doing well for many decades, and allow NASA's expertise to focus on more of those long-term challenges to go to deep space. And that's really the SLS kind of PCV, the Orion program. That's what they're really focused on. But this is really connected to that being able to happen.
Great. Next question.
Hi, I'm Elizabeth from Science World in Vancouver at Science World CA and NASA Social. I'm curious about, since the shuttle program ended, what are some of the specific or particular benefits of having to work so closely with the Russian space program that you found?
Well, we've always had, we've had a good relationship with the international partners, and Russia is one of them. But the space station itself is a testament to all the partnership internationally. So not just the Russians, but the Japanese and ESA. And so it's the broader international community. With the Russians, I think we've always had a good relationship with them. They realize that we're more dependent on them, There's really no major concerns. It's just a matter of us having the capability and the flexibility as an agency to be able to have a backup in the event that we need it, or just the added capability, period, increase.
Like because of the extra lean on the relationship?
Mm-hmm. You're asking if they meaning the Russians have had to add?
Yeah, as a result of the extra.
No, we just have it. We've had, I don't think they've had to add anything like to their capability, if that's what you're asking. The main thing is we just have to, as an agency, buy the missions from them. It takes a lot. There's a lead time, and we have to manifest our crew and our missions pretty well ahead of time. And so it's probably put more emphasis on that partnership and that contractual relationship, I guess I would say. Yeah.
Another question here.
Hi, Casey Ayers with NASA Social. A follow-up on the difference in philosophies between the Boeing and the SpaceX approaches. On the road to human certification, SpaceX has been perhaps more publicly visible so far, things like the abort test a few months ago and so on. And I think that the CST-100 timeline seems to put more of those more publicly visible steps near the end. Is that more a matter of the practicalities of, they're starting from kind of the Dragon and Falcon 9 kind of established point, you're building something from scratch, or is there a difference in philosophy that's behind kind of the difference in how you slate that checklist getting checked off?
Of course, I can't speak to SpaceX's philosophy, but I'll speculate. There's philosophies that say build a little, test a little, fly a little. There's philosophies that say, hey, I have the capability. I've been doing this for several years. I'm going to build it. It's going to fly. It's going to work because I'm going to certify it. And I have the engineering tools that when I launch that product for the first time, I just know it's going to work. So I go back to Boeing's commercial aircraft division, right? When the 787 came out, nobody wonders, is it going to fly? Of course it's going to fly. We have tremendous tools. We know how these things work. We know their intricacies at this point. So I think it is just a subtle philosophical difference on development. When you see all these test points come together here in late 2016 and going into 2017, of course, we have utmost confidence that we're just going to knock these off, and the test point itself is just academic. So I believe there is a little bit of a philosophical difference, but there's no less rigor applied. And when you see the test points begin to come off, like I said, they're going to come off in pretty quick succession.
Thank you.
Val, did you have a question?
Hi, Val Phillips, Zero G News. With the potential problem with the budget, how is that going to impact potentially with the seats up to ISS? Are you going to have problems in respect that you might have to go back to the Soviets for more seats? Sorry, the Russians.
Yeah, so we'll have to, assess what we can do and the timing and how that the budget impact really impacts our schedule, obviously. And if, if we don't have the capability ready in 2017, we have already purchased missions from the Russians up until I think the last one is in 17. But we periodically look at what we need to do looking forward and when the next procurement, I guess, or the next order of a mission from Russia would be. And at that time, we'll just keep looking and see where we are and when that decision needs to be made and whether we are ready with the commercial industry or if we need to continue buying another mission from them. So that's just something we'll look as we go forward.
James has another question.
Thanks again, James Dean, Florida Today. And just, I guess, setting aside the budget uncertainty that will remain uncertain for a while, you've been referring to having a very aggressive schedules, and on the other hand, you have, milestones mapped out that you're confident, will test well once you get to that point. And I'm just wondering if you can kind of characterize the confidence in assume that you have the budget you need in making that late 17 timeline. Is that an aggressive, everything has to work perfectly schedule, or how much margin do you have in there at this point? Yeah.
There's some, and we are trying to make more. Right now we have some critical path elements that we're trying to relieve. In other words, test a little bit earlier on perhaps a different platform to give us some additional margin. So, by no means is our schedule completely cemented yet. There are dials that we can turn to try to alleviate risk, bring things to the left to give us some latitude. It's a success-oriented schedule. There's no question about it. But we're very confident when we get there, we're going to have we're going to be successful. And if not, we'll fix it. We won't fly until we're ready, until we're safe.
Chris, you said or talked earlier about redundancy with the Russians in the past and everything, and having redundant vehicles. Gary from Twitter is asking, will U.S. astronauts still launch on Russian rockets at times, and Russian astronauts launch on U.S. rockets?
I think it's a question more for Lisa.
Yeah, so I think the plan right now is, to have an interchangeable kind of, we would continue having maybe a Russian crew on the commercial side and vice versa. That's still an option.
Okay, great. Thank you very much for your time, Chris. Thank you for joining us. We'll now watch a short video about the SpaceX pad abort test that happened recently, and then Hans Königsmann will talk to us about the progress SpaceX is making. So joining us now from SpaceX is Hans Königsmann, the Vice President of Mission Assurance.
Good afternoon. Should I just start?
Go ahead.
All right, good. I mean, you just saw the pad abort video. I'm not sure we should show it again later, or is that? It's a perfect intro, actually. I did wanted to comment over it. What you saw is basically a couple seconds of full thrust of the Crew Dragon. Here we go. It's looking. This is the same launch pad that Falcon 9 at Slick 40 uses. Same border system. Here we go. A couple seconds full thrust, and this is really fast in a hurry. This is shut down there, and then when you see it from the outside, there's a trunk on the Dragon that keeps it a little bit further up, and it's also for cargo. Here we go. Here goes the trunk. There's a short view where you see the VIB on this video. It's really very beautiful. And then comes the two drogue chutes, and then the three mains. It looks a little bit, like a lot of motion there, but it just orients the capsule in the right direction and makes sure that the astronaut land in the water in the right position. So this whole system, that test happened not too long ago. It takes a while for it to come down and to land safely in the water. Crew Dragon, one of the key features is the paddleboard system. It's integrated in it. It uses its. When you look at the Dragon, there's 8 Super Dracos, as we call them, in double packs around it, and they use the same propellant as the on-orbit thruster. And the idea is basically, why not use that propellant either for your paddleboard, or when everything works well, then you have more performance in orbit. And since it is integrated, it's a great way to test it. In our opinion, it's a really safe system. And it worked perfectly on this case. Really happy with that particular test and that particular start here. All right, going back to Crew Dragon, Falcon 9, I just want to point out that both Crew Dragon and Falcon 9 have been designed with astronauts in mind from the get-go. When we started SpaceX, I want to say 13 and a couple of years ago, manned spaceflight was always on the table. It was always something that we considered. It was always something that we based design decisions on, and it is something that obviously plays in your daily work when you ask, so is this safe for humans? Can we fly astronauts with that? That has an enormous impact on the way you design things and on the way you lay something out, on the way you build redundancy, on the way you consider fault tolerance. So both Falcon 9, and I got to point out, Falcon 9 and Crew Dragon are basically designed under the same roof, the same company. In many cases, same people. I work on both systems. So there's a lot of crossover in terms of technology, in terms of experience, and in terms of, and also really important lessons learned. Yeah. So. Both elements, rocket and the capsule, are designed for maximum safety, maximum reliability when it comes to the human space flight. So that's one part. The other part, of course, is since we use the Falcon 9 on several other payloads, we fly satellites with it, and obviously we're flying the Cargo Dragon right now. That gives us a lot of opportunity to actually learn Falcon 9, see where we can improve things, how we can make it safer, how we can make it more innovative, and obviously that plays into reusability at the same time. How can you make this vehicle cheaper to some extent? How can we make a Dragon more reusable? All those things work when you have the opportunity that we have with NASA supplying the ISS. We are really grateful for that opportunity, and it's just a unique. I'm just really happy to be here. Okay. All right. So that's about Crew Dragon and Falcon 9. The work on Crew Dragon itself is going great. After paddleboard, there's a couple other milestones that happened this year. We're working on an avionics test bed. Doesn't sound quite as exciting as the paddleboard, but it's a really, really important tool. That's how you test your entire vehicle. You can basically fly the vehicle on the ground. You can sit there, flip the switches, or the touch screens, or whatever we're using. You can test the algorithms. You can test everything, the batteries. Very, very important to get this right before you start putting it into the capsule itself and then do the next test. We work on structural model. We do work on a propulsion module test coming up here. Let's see what else. We had we're also working on the launch site. Not to forget LC-39. This is really incredible. I would not have thought that 2 years ago that we one day would just walk on the same ground where Apollo and the shuttle launched. That's incredible for us. So we're working on that path and getting it ready for the upcoming flights. There's a launch operation readiness review coming up here later this year. So there's a whole bunch of activities that are related to Crew Dragon. By the end of the year, there's a big design review, final freeze and design, with all the lessons learned that we learned along the way, whether it's paddleboard or the avionics test bed rolled up into this one test. And then a little bit the one thing I really like on the internet, on the docking adapter here, it's a really perfect crossover right now. It sits in the vehicle that's right now on the pad a couple miles from here, and it's the key stepping stone for us. If you put this on the station, that is the part that Crew Dragon is designed to actually attach, and so I think it's a really really important and significant part of hardware that we bring up, and I'm also really thrilled about bringing real, not just food and clothes and things up, but also science experiments, worms. We will treat them very well, and and then bigger science experiments like cameras or whatever, and then actually this particular piece sitting on the outside in the trunk and Dragon will get extracted by the arm and put somewhere, and then from what I understand from Mike Saffredini, a very complicated way of flipping notes around will happen before this is ready for us then on the first Crew Dragon demo flight. That's pretty much what I have from Stardust Crew Dragon at this point in time.
Great, so we'll take some questions. Looks like James has a question. Remember to raise your hand, wait for the microphone, and if you want to send a question using Twitter, use the hashtag AskNASA.
James, Dane, Florida today. Hans, what's the timing now for the in-flight abort?
Yeah, so we looked at the paddleboard. We're still looking at the data there, and it's basically that was the first flight test of the Crew Dragon. We're going back and are considering where the in-flight abort fits next, and what is the best place, what's the best value at this point in time on the in-flight abort related to what we learned on the paddleboard on the overall schedule. So I can only say it's right now in flux. There's going to be a better announcement than that shortly.
Okay, Ken.
Ken Kramer, Universe Today and Northeast Astronomy Forum for Hans. Two questions. One, same what I asked Chris Ferguson. When will you have the first flight vehicle ready? And the second is when are you going to pick the astronauts or the team of the astronauts that will actually fly? Thank you.
Let me start with the question number two. So in our case, the astronauts are picked by NASA. We decided it's the best for our part of the program to have NASA make that decision and help train the astronauts, and so that is not something that I know at this point in time.
Yeah, no, we have not decided on the crew yet. We're talking. We have conversations on that, but we have not selected a crew yet.
When, Mike?
I don't know. Shortly. Soon. Soon. We'll have to. Pretty soon. It's really a matter of backing up from the training that's required and knowing when the right time is to make sure that they have a crew, to get through the training period that we'll have.
Okay.
And then regarding the demo flights, end of 16, early 17 is the time frame right now.
When will the vehicle be ready, though? When are you going to start building it and finish
So there's going to be several vehicles that we build. There's going to be qual vehicles and then the first flight vehicle. It's going to be ready just to meet that time. Basically, I don't know the exact when we have the vehicle here. It's going to be ready in time for that end of 16 first flight. And you're probably referring to the Crew Dragon, not the Falcon. Yeah, okay. Because Falcons roll off the factory right now at a interesting pace.
Okay, thank you.
Other questions? Social media? Have we gotten anything on Ask NASA? No. All right. Well, if there are no other questions, then we will conclude our briefing for today. Thank you so much for joining us as we prepare for the 7th SpaceX Commercial Resupply Services mission to the International Space Station. Launch is scheduled for 10:21 a.m. Eastern Time tomorrow, and our launch coverage will begin at 9 a.m. Please join us then for live coverage of the launch and the mission. You can follow along with all the developments made in the Commercial Crew Program at www.nasa.gov/commercialcrew, and all of the preparations for launch at www.nasa.gov/SpaceX.